Number 4, we are going to graph the function, and on the graph, we want to identify any of the asymptotes or intercepts. Okay, on your graph, we want to identify those. So notice that this problem is like number 3, and it's like number 3 because what's the degree on top? 2. What's the degree on the bottom? So in that case, you will always have a slant asymptote or you'll have a hole. And the only way to determine that is, can we cancel at the bottom? So let's see, can we factor this? What multiplies to give us -4 or -12 and combines to give us 4? That would be x plus 6 and x minus 2. What's the biggest thing students are going to forget to do? Bottoms up. Divide by 3. So I have x plus 2 when I divide, and 3x minus 2. That's the numerator over x plus 2. So this is what I have when I rewrite it in a different form. What's going to happen next? Okay, and remember, when you cancel out, does it just disappear? Really, it turns into what number? Okay, so is this going to be an example of a hole in a graph or an example of a slant? Hole. Okay, so I've got that down. So I know this is the equation. When I graph it, this is the equation I'm going to graph. So I'm going to do that right now. Okay, I'm going to start at -2, and I'm going to do it just with dots right now. I'm going to go up 3 over 1. 1, 2, 3. 1, 2, 3. 1, 2, 3. Down. 1, 2, 3. 1, 2, 3. Okay. Just like problem number 3, we can always determine the vertical asymptote by taking the denominator and setting it equal to 0 and solving. So x equals -2 would be our vertical asymptote. So I find -2 and I make a dotted line. What does this mean? It means when my line, which I'm going to start to connect, when my line crosses over the vertical asymptote, there needs to be a hole at that position. Here's my graph. Where does the hole always occur? It occurs when it crosses over the vertical asymptote. No other place. The hole occurs when it crosses over the vertical asymptote. So I've identified right now, I can see what the vertical asymptote is on my graph. I can see that I have a y-intercept of 0, -2, and I can see that I'm probably going to have to use a graphing calculator to identify the X-intercept. So let me do that real quick. Second plus 7, 1, 2. I'll plug in what I have. 3x squared plus 4x minus 4 divided by x plus 2. And let's figure out what is this X-intercept. Second trace value, second trace 0, my fault. So I'm going to go left, right of it, and back to it. So rounding to the nearest tenth, it would be 0.7 as the X-intercept.